Welcome, folks. Azure Cosmos DB TV. I'm Mark Brown, episode 98, and I've got some friends with us from Bizmetric. They're a partner of ours on the Cosmos DB team and at Microsoft, and they're going to share with us something cool they've built. I think probably most of you have been busy looking at things like OpenAI or just generative AI in general, and they've built a pretty unique solution and they're here to share it with us today. So, Ishwar, Vishal,
Yeah,
nice to meet you, gents. How are you?
yeah. Thank you so much, Mark. I'm good. How are you? And thank you so much for this opportunity to you and Microsoft. Here, myself, Ishwar Sukheja. I'm practicer DIML Bizmetric. Here to present one revolutionizing application for IVR system, which we have developed for a lot of banks and 15 clients all over. And we are currently developing much more applications. So, Vishal, I would like you to just share the screen. Thank you so much.
Yep.
Uh, yeah, about I'll just go through some table of content, which is about Bizmetric, our IT solutions and services. Then we'll get into the Gen AI application, what we have developed for the customers. Please go to the next slide. Thank you. Yeah. So about Bizmetric, we have established in 2011. We are Microsoft Solution Partners Data and AI. We are the finalist for 2024 Microsoft Partner Year of the Year Awards. We have overall 20 plus experts of Cosmo DB. We have done over deployed in production 15 plus generative AI applications for different banks, retail, construction industries, and we are continuously developing that. Our head office is in Pune and US Houston. Yeah, please next slide. We offer different solutions, services in data and AI, from data lake solutioning, data engineering, data governance, AI, using machine learning, Azure ML Studio, different ML ops services, Azure Analytics, big data, generative AI, what we are going to talk about, Lakehouse, Microsoft Fabric expertise we have. We are the first Microsoft Fabric F128 implementation in India, and we proudly say that. Yeah. So here we are going to discuss one customer service bot, which we have replaced the IVR system for one of the banks. Um, can we go to the next slide, please? It's a API-based customer service bot where we have transformed the IVR into conversational excellence using the LLM-based solution of Azure Cognitive Services plus Azure Cosmos DB. The business challenge here was the end users were difficult to navigate to the computerized numeric keypad access services. It is not always that we can implement the user friendly IVR system. We can give all user information in that IVR system through numeric. It is very dissatisfaction for the customers, and it is always difficult to integrate IVR chatbot with the existing systems. The
Yeah, I think we've
user,
everybody's been through one of these IVS before, where they're frustrated. You
yeah,
push
correct.
some
You know,
number and then you
right.
go somewhere and then you're like, that's not right, and then you have to start all over again. So this is cool.
Yeah. So our solution, we have leveraged Azure Cosmos DB for context over natural language interaction. User enjoys dynamic real-time conversations surpassing traditional IVR script-based system. It is faster, it gives very accurate results, and it is multi-language. It can be English, any other different Devanagari languages also can be inbuilt. The key result is it is the customer gets very fast result and it is very interactive. The accuracy is very high. There is a lot of cost reduction. There is less manual intervention in IVR system. There are a lot of time people tend to talk to the agent directly, but in this there is a raw cost of reduction because the agent cost goes very down. So you can see we have developed it for a lot of customers, which is Canara Bank, HFCL, Dream 11, TVS, Simrol, and many more. We are currently implementing it for many more banks. Yeah.
Fantastic.
Can you go to the next slide, please? Yeah. So we'll go through the application workflow. We'll understand what is the data ingestion, how the data ingestion looks like, and how is the workflow for this. And then we can go into the system architecture slowly. So here we can see there are two, and on the left hand side of my screen, there are two data ingestion. One is the user database, wherein the user specific data is there, which is MySQL DB in this case, which is the on-prem database. And then the data is ingested through different APIs. The APIs can be loan API, foreclosure API, maturity API. It depends on the banks how much APIs, and it can be many more APIs. The other documentation is the frequently asked question data sources, which is mainly document forms, or it can be mainly some how can I close my loan. Okay, what form I can use, what is procedure to update my PAN or any other information. That is more of a uh, document related thing data. So that data is ingested through the PDFs, and then those PDFs are uploaded to ADLS Gen 2. From there, we do document chunking and use document intelligence service, which actually does OCR on these documents, and then that is vector embedded into the Cosmos Azure Cosmos DB. So this becomes a RAG system from here, and then we using the OpenAI function APIs, we are actually fetching the user information, the user logs using the web app, using mobile OTP authentication method, and through the Azure OpenAI functions, we are actually now routing it to a proper question. If the user asks what is my loan account number, so now through the OpenAI function API, it understands that it is a user related information which it is asking, and there is a prompt engineering done for this same, and it goes and fetches the user related account information from the database, and it represents it on the UI. Similarly, if the user asks, what is the procedure to close the loan? It is more of a generic FAQ question, which will obviously come from the PDF. So it will go to the Azure Cosmos DB, does a vector search, and it represents it will actually give a proper link to the form and shows on the UI. We will see the demo shortly. Vishal will help us showing the demo of the same. Can you go to the system architecture, please?
Can I ask a question before you move on?
Yeah, sure.
Maybe you'll show this in the demo, but can you talk a little bit about the data extraction that you're doing in there? I'm guessing this is taking kind of the raw user data on the loans, foreclosures, maturities, all that kind of financial data, and that is you're basically taking and extracting specific properties or fields out of that data and then generating vectors on it. Or can you explain that whole process for the data extraction?
Yeah, Vishal, can you answer that?
Yeah, so basically, Mark, like we are extracting data from a PDF, and on the PDF we have lot of like tabular information, lot of different data structures are there. So for that purpose, we have used this one of the tool from the Microsoft, that is the document intelligence. So basically, this document intelligence actually trained on to extract this tabular information. It is good in that. That's why we have added one more component, that is the document intelligence. And once the data extraction is done, then we are doing the further thing like the chunking, splitting, and then we are doing the vectorization.
Got it. Did you define a schema for your data so that you basically had like a model management kind of functionality in there so that you basically schema management, I guess, so you knew what you were extracting, pulling in.
Yes, so we definitely we have created a proper schema and the proper pipeline for that. Let's say the new document is added into that specific Azure blob, the automatically code trigger and the further pipeline started. So answer to your question, yes, like we have created that schema.
Got it. Got it. And then the same thing for the user data as
Yes,
well.
so
That
basically, like if you talk about this use case, so on broadly we can classify the whole problem into the two way. One is the we are storing some proprietary data into the Azure ADLS, and another like we are directly using the APIs for fetching the
Mhm.
data from a different databases. So here we are fetching the data from a SQL DB, and as a knowledge base, we are using the proprietary information from the client.
Yes,
got
and obviously because the user data will have a proper schema, right? Because it will have a proper schema to it, and we are pulling that as a structured data. It will have a proper schema to it, definitely.
got
Yeah,
it. Got it. Okay. Yeah.
yeah.
Go ahead.
Let's go to the next option, system architecture. So you can see the system architecture here on the left hand side. We have used GitHub Actions to deploy the Python backend application, which is a fast API developed application which is deployed on web apps. And then we have, it's a microservice based architecture wherein the front end is deployed in, it's developed in React.js, and the back end is in Python. Both are deployed using CI/CD method. And then we have used a complete secure environment wherein we have different VNet, subnets, private endpoints, which are linked to each and every services differently. Here we have used multiple applications so that there is a proper load balancing done. If there are concurrent users, many users, then it should shed the load and actually be highly available system. Even there we have deployed two ChatGPT 4 turbo models here, so that the system is highly available. If you can see, there is a WAF also implemented here, wherein we have added the payload rules. We have added a lot of different rules which are which makes it a highly secure environment. Okay, and the authentication is their mobile OTP authentication, which we take it from the third party directly.
Got it. So you're running multi-region for this solution?
Yes, it's a multi-region solution.
Got
Yeah.
it. It's is it active passive in terms of its setup?
Yes.
Okay.
Correct. And the logs, complete log monitoring is done using the app insights, wherein we can, it is very easy for us to debug the system. Once we get into the code, we'll understand, we have done a lot of exceptional handling where we can understand where we can debug the code properly if it in case of failures.
Got it. Are you in terms of the kind of the data consistency on this, are you running like an RPO zero, or is it, or it's, I'm guessing you're running for RTO zero here, right? So you want to keep availability high?
Yes.
Okay.
Yeah.
Got it. Yeah. Okay.
Okay. Yeah. Can you go to the next slide, please? I'll hand it over to Vishal here for getting into the much details of the responses and the technical aspects. Vishal, over to you.
Yeah. Thanks, Ishwar. So before a deep dive into the technical details, let me first give you the high level understanding about the business problem. And I mean to say we are addressing, and then the solution we are implemented, and the key features we added to make this bot very powerful. Okay, so the key thing for developing the key thing before, like, for developing this model is like we want to develop something that can gives us the responses in the natural languaging, and that should be a very sophisticated way. And I think that we have already achieved with this use case. So we'll directly go over the implementation challenges and the realization part. So as I discussed earlier, so we have developed a advanced system combining the retrieval augmented system RAG and the API based functionality. So on a high level, the whole problem we can classify into two parts. One part, like where we can build the RAG system on a proprietary or a domain specific information. This include different sort of PDFs, guideline documents, internal documents, the change request documents. And the second part, where we dealing with the structured information, we have created a API based solution here. So second part, we have API based responses for a personalized question, such as the details based on individual account number and the OTP authentication. Let's say allow us to provide some personal data like amount, what was the EMI detail, minimum EMI that I need to be paid, the payment due detail. So such kind of personalized information also we can fetch from the specific system. Okay, so I think I will quickly give you the high level demo how the actual system works. Just let me know like when my screen is visible, like
Yeah.
yeah,
Yeah.
okay.
Good deal.
So this is the very first phase. Here involves the authentication using your account number followed by a OTP, which allows us to log in into the system. So I have created one random thing for this. So I have entered one account number and I just click to the generate OTP. So meanwhile, the OTP generation started. Okay, so I will enter the OTP. Okay, so this is the landing page. From here, we can ask the both kind of question because we have already done the authentication. with our account number. So we can ask the personalized question which is related to you only, and apart from that we can ask some generic question which is related to the anybody, like we can ask the generic question also. So basically I will start with the few question to just let you know how the bot is working. So this is the solution we are developed for one of the BSFI or the financial client. And so basically let's say if you ask one question to the bot, so let's say what is my loan status, okay. Okay. So I asked the same question to the bot, what is my loan status? So the bot is answering while fetching my personal information. The loan status is active. Okay. So according to the same question, I will ask another question. How many EMI have I paid? Yeah. So you have paid total my 19 EMIs. It answered. Let's say I will ask one more question, like how many EMI left? Okay, so it will give us the answer about how many EMI still left. So 19 we already paid and 5 are left. So these are the some personalized question we can able to gain the more, and we can able to gain the more understanding about this personalized question, because we have integrated this APIs with the DB, so that they can face the answer from there only. Let's say if I want to ask some generic question which is like from the guidelines document or something, I want to do some kind of change request. So let's say if I ask any random question, how to change the nominee. Yeah, so it actually gives us the better idea, the process to change the nominee. And I have just written I have done the incorrect spelling of the. So bot has understanding about it, actually automatically check the spelling and correct automatically. Okay. So here you can see it gives the we are able to see the answer. So what is the process to change the nominee? So let's say I want to ask another question, how to update. So I am just asking the one question, how to update the email address. So again, the bot is giving that answer, which is from the proprietary documents only. Okay. So let's say if you want to see the capability of our bot, let's say if you ask the question in a multilingual way, let's say मुझे अपना email address change करना है. So I asked
That
this
is
question into
English.
the English. Okay.
Yeah.
So definitely bot will answer in that same way, like आपको अपना email address update करने के लिए you have to follow this following process. So you can see the bot capability here. uh, can we move to the
Yeah.
next part?
Any questions, Mark, on this? If you
Yeah, I do. So you've asked it questions on how to do stuff. Does this thing have kind of agent capability where it'll actually go and say update your email address or change something on your behalf?
Yeah. So this is the second phase of our pro development. Initial phase, we are only retrieving the information. So next phase, we are trying to add some adaptive learning here, so that bot can understand and do the further thing depending upon the what kind of task we are requested. So
Yeah.
this is in the development phase.
Yeah. Okay.
Yeah.
Yeah. A lot of apps are moving to this way, like asking
Yeah.
questions and how to get information. But it's just the next logical step is okay. Well, do that for me, would you please? And yeah,
Yeah, like
yeah,
the people want something like adaptive learning, something like a Twitter persona. Yeah.
yeah,
yeah,
Okay, so I think now we directly move to the next step, where like actually we have integrated so many things, and I will just quickly give you the overview of whole end-to-end architecture and the end to end, like what are the steps we have followed for completing this whole process. Okay, so definitely if you talk about any rack system, the very first step, like we have a PDF document, we have a lot of unstructured data at the input stage, and finally we are asking the question from the prompt side. So in between that, the whole rack system is actually divided into the more than 7 to 8 subcategories. So the very first category where we can do the PDF injections. So here we are using the PDF as an input, and we have uses the document intelligence for text extraction, or you can call it as a OCR. Once that step is completed, one of the important steps comes there. We want to do some sort of data splitting, or we can say chunking of the information. So we have tried multiple mechanisms for chunking, and we are strict with the recursive chunking. Here we are getting the really good results. Once that chunking process is completed, the next step, we want to vectorize the information in the form of vectors, or we can say conversion of information number into like text to the number. So we have just the Azure AI, this OpenAI embedding for that purpose, and then we are storing this whole information into our Cosmos DB. So this is the key thing. So this is an indexing pipeline. Here we have completed the indexing pipeline, and then the retrieval pipeline started. So during the retrieval pipeline, what happened? We have three important components. First is the search and the retrieval, another is the augmentation, and finally we have generation. So let's say as a user, we ask some question to our model. Let's say we ask the one of the latest question related to the latest topic: who win the 2024 T20 World Cup? So this is the question asked by the user. So on a fly, the embedding happen, and that questions, or you can say that embedding hits to the vector DB, and it try to fetch the similar thing present into the vector DB. So once that fetching process started, the very first thing comes into the picture, that is the augmentation. And the augmentation is the key, because during the augmentation, what we are doing, we are fetching the information from a vector DB. We are doing some sort of sophist, we are just adding this context into our prompt, what are the prompts we are given, and finally we are trying to build our answer according to the user asks. So this whole, like these three processes we are performing during the augmentation, and finally we get the answer into the natural language processing. Yeah, so these are the high level I mean to say pipeline of any rack system. So my interest is a little different to, I want to showcase you a few new things here. We can directly go over the coding part. There, I want to show you a few things. Okay. Let me know like when my notebook is visible to all.
Yep, I can see it.
Yeah. Okay. So as discussed, like we have completed the initial rack pipeline. So here we have added a more feature, that is, if you see the point number 6, we have integrated a session management here. Again, we have done the different agent interaction responses handling here, and also we have done one of the new capability, that is the streaming responses. So if we talk about the session management, what we have done in the session management, we are handling the continuous conversion and tracking the user information seamlessly. Let's say Mark is the person, and we are fetching the information about the Mark with the help of some unique ID. So here in our case, the unique ID is what? The Mark's account number,
Hmm.
Mark's bank account number. So we are storing the whole interaction about Mark with the generic ID into the MongoDB server, so that that information can be used to gain the more historical understanding. And also, let's say this information is helpful for lead generation or the marketing purpose, we can use information directly as a business owner for the further thing. That's why session management is very important, and we have integrated the same thing here. And also we have added a different agents for a different purpose. Let's say for fetching the data from RAG, we added a different tool. For fetching a data from API, we added a different uh, tool. And we have integrated more than 30 APIs here for fetching the information from different things. Okay.
So, can I ask some questions about your
Yeah,
session
sure.
management? So, So I get you're storing chat history, right? Like you need to provide a context window for the LLM to generate a completion.
Yes.
Are you going a step beyond that and caching or saving kind of past questions like what's my account or what's my EMIs left or other stuff, and then using that to basically short circuit a vector query into the larger knowledge store, or go into more detail because
Okay,
it was
okay, okay.
interesting what
Sure,
you were
sure.
saying there.
So, okay, I will explain you this term. So basically, along with the Cosmos DB, so the basic use of using the Cosmos DB, MongoDB vCore, we can use this as a vector store, and along that, we can use the MongoDB as a NoSQL server. Okay,
Mhm.
so into the NoSQL server, we have that ability to store the transactional information, the chat history,
Yep.
the historical information. So we have stored a side by side into the same, we can say, in the same place. Okay. So it is very easy and flexible to interact between each other. So the main purpose of session management to fetch the details of that specific person based on some unique ID, and another purpose to store the historical understanding, so that let's say, Mark, like you ask few question today and you log out, and after a week you again started asking the question. So after the week when you ask the next question, definitely the that session will goes to the last week interaction and face the historical understanding,
Okay.
and then it will give the answer based
Got
on the last.
it.
Yeah.
Got it. Okay. Yeah. So just maintaining kind of that past session history so that you
Yeah,
can
Yeah.
refer to it. That's providing that context
yeah,
window
and that
for.
reduces the cost also. It
Yep.
reduces the cost of OpenAI requests, right? That
Yep.
reduces a lot of cost. Yeah.
Yep. Okay.
Yes, and there might be a question, like many people having the question, like, then what is the benefit does the customer service bot gain using this Cosmos DB or this MongoDB integration? Okay, so I will just answer this question. So basically, what happened into Azure Cosmos DB, MongoDB vCore? So we can storing the definitely embedding into the Cosmos DB, indexed and the query alongside with the original data. So that what happened, this approach eliminates the extra cost of replacing the separate data for a NoSQL database for a NoSQL, separate data for storing vector DB. So we can do it on a same fly. Okay, and moreover, like this architecture keeps the vector embedding and original data together, so it's very good to retrieve something on a very quick basis. Okay, and now we'll go over the steps what we have followed while developing this whole application. Definitely we have just the langchain as a framework,
Hmm.
and we have just the Azure AI stack, whole Azure AI stack for the development of this whole application. We have just the different cognitive services starting from the document intelligence, Azure Blob. We have just the different embedding things from the Azure AI only. So we have just the Azure AI only. And as a natural languaging model, we have just the GPT-4, the earliest version. Okay. So here in the first step of the code, you can see we have initialized the so many basic thing which is needed for the further thing, and we have setted a temperature value as low as possible because we want some deterministic output. We don't want to be a more creative while providing the answer to the our asked question. Once that done, the next step we are just connecting our Azure DB for embedding purpose, and also created a one Mongo client for storing the historical data along with the chart history. Okay, and if you talk about the retrieval, so here definitely our retrieval, or you can say the vector store, we are uses this Cosmos DB, and it actually work on the principle of semantic similarity. It's the default function we have used here. Okay, so now we'll go on other stuff. Just a minute. Okay. Okay, so now we talk about one of the again one of the new one of the innovation we have added here. That is, we have done the API management here. So what exactly the API management and how we can handle so many things here, that I will explain you one by one. Okay, so so initially what happened, let's see. uh, all the APIs were integrated within a specific function only. when the client API was authenticated using any bearer token or the application ID, the definitely that function calls and the whole functionality happens into the JSON's format only. And the based on the intent of question, this is the one of the important key line. The based on the intent of the question, OpenAI will choose the relevant tool and call the particular tool. As I said, like we have integrated more than 30 different APIs now. So here the intent is very important. So understanding the intent, it will just trigger the specific API. Okay. So uh, also like Ishwar is already mentioned, like we have just the two GPT version here. So the reason behind using two is like, let's say, as we know this we have done the API management because we want to control the traffic. And if we talk about any Gen AI or the LLM model, basically we are facing the issues of contextual context window. So let's say for one of, like let's say someone is asking the questions, and in that case our context window is exhausted, then definitely what happen internally, it checks and it moves that topic to the another OpenAI, or you can say the another GPT. That's why we have made this API management here. Then you can see like in the code only, we have already added so many responses. We added a different statement to check the feasibility of each and every variable present into the bearer token and the app token. Okay. And here we have created a API client, API client as a class, so that we can call everything into the single function only. And for getting the details from different APIs, we have created a separate function along with the separate tools. Like we have created a loan get loan status detail, this is one function. Then we have created a response status, then we have created get overdue details. So we have created a different tools for fetching the information, I mean to say. Okay. So the prime goal of integrating this whole thing is like, first I have to made a progress on the token management for OpenAI with the Azure API management. Next thing that I want to achieve, like let's say I have added a two different instance of OpenAI to set up and for systematically to automatically switch the system internally. And the final goal is to just second instant, like let's say the first instance facing some traffic issue related to
Mhm.
the token limit, it will directly fetch to the another.
Got it.
Yeah.
Oops, sorry. Are you also using it to kind of rate limit users as well? Like if they're,
uh, uh,
or you're just using
can you
it to
repeat?
load balance basically across
Yeah,
multiple
yeah,
models?
this API management we can call in a different way as a load balancing also.
Got it. Got it. Got
Yeah.
it.
Yeah,
Yep.
and yes, obviously the rate limit is configured here, but that is using the WAF policy.
Okay. Does it rate limit users? Like if users asking too many questions or like, I don't know, something that's just
Uh,
chewing up a whole ton of tokens?
not not to the users.
Okay.
It can go. It has token limitations, but to the logins, obviously we are doing some rate limiting, payload limiting to
Are
that.
you, what about the pay? Yeah, I was going to say, so explain the payload limiting, right? Like this is a common kind of task for building these LLM pipelines is how
Yeah.
much chat history do I put in? How much RAG data do I put in? There's usually some kind of balance you have to kind of maintain there, right? You don't want to lose too much context because the LLM
Yes.
may not have the full context, and you don't want to lose data either
Mhm.
because it needs that to actually accurately answer the question. So, can you describe kind of how you manage that balancing act?
Yes, sure. So basically, at a very initial stage, like when we are using the very early release of GPTs like GPT 3.5 or the Turbo, that time we are facing the issues of context window because we have very limited token size. Initially we have 4096, then it goes to the 16K. Now we have enough token size. So we have setted that parameter. So we are storing the last 10 transactions, or you can say last 10 chart histories of that one person, or you can say one session ID. So that
Okay.
from that 10 chart history data only we can retrieve a historical thing.
Okay, got it. So you're using chat history like a cache.
Yes.
Yes.
Okay. Okay. Yeah, makes sense. Okay.
Yeah. Okay, and this is the another part. Like as I said, now the whole process is based on the intent of the question, intent and the extent. So these are the like here you can see we have created a code to get loan details. So in the get loan details, we have categorized the whole information into the different types. Like for a loan summary, we added something for a next EMI. So let's say if we talk about the first thing, the loan detail. So the user asks the question, and which is the intent of that question is based on that first 4 to 5 option, then definitely the first API will be hit. So this code indicates the same thing, the intent part. Okay. And here, like the same thing, this is another API we have integrated here for get overdue details of that specific user. Let's say the question related to the list of month wise total overdue details. Let's say the minimum cost that I need to pay. Some such kind of questions are there, then definitely this get overdue details API is triggered and it will fetch the information. Okay. And yeah, so now we are into the final part where I can showcase you how we can integrate this session ID. So definitely we have uses the LangChain capability here. So in the LangChain, we have that capability to integrate the session ID. So here you can see the session ID is equal to SCP-01. So here like I have created one random ID, and under that ID we can store this whole information in a dictionary at the MongoDB instant. Okay. And yeah, so this is the same thing what I have just trying to tell you. Here we have added the context window as a 5. So it's depending upon your which model you are using. Let's say you are using the GPT-4, it's having the very large context size, you can increase the context size. So as a cache memory, I have just added the 5. Okay, like I think I'm actually done with the just explaining his whole code. Like Mark, like you have any question regarding the development or we can say programming stuff?
Yeah. So, um, I guess in terms of load testing or anything like that, were there challenges you came across when kind of working through this? Like, um, and I think you solve that in one way by deploying a second model, which is I think probably
Yes, yes.
a way you could go about that in terms of just trying to handle increased numbers of users. Is that kind of your strategy, I guess, is if you need to scale out in this regard and you need to handle more and more users who are going to consume more and more tokens, that's your
Yes,
that's your strategy, right? Because you need to keep the query per second or just request per second, a decent level, right? Like LLMs are not speed demons by any means, but people don't like waiting for questions, or they may
yes.
think something is wrong if they have to wait a long period of time. So your strategy, I guess, for that, or challenges did you encounter when trying to run this type of thing under a heavy load?
Yes, like
Yeah,
that the same challenge we are facing, like, and we already tried multiple scenarios to overcome that. Yeah, and apart from
yeah,
that, like,
that's the reason we have integrated two ChatGPTs, and then if the traffic goes very high, more we can integrate more, and but that's the capability. That's the reason we have kept that capability, and that actually solved our problem.
Just basically adding more models, more deployed models in.
Yes,
Yeah, yeah,
yes,
yeah.
because it's pay as you go, right? So it doesn't matter how many we add. So that doesn't impact the cost, but it made it really highly available.
Were there challenges with just latency that you dealt with? I mean, you used that cache there that you were using in the
Correct,
chat history. Were there
correct,
other strategies and tactics? Like one of the things I kind of see common with users is they tend to ask questions that you don't need a vector search, or you don't need to go and do anything really complex. It could almost be served from like a frequently asked questions knowledge base of like just some simple
correct.
answers and stuff. Did you employ tactics like that with building this?
yes, yes, I answered this question. So yeah, so apart from this whole development, we have fine-tuned our model based on some FAQs. So we are like while just sitting with the business owner, we understood so many domain specific thing and the frequently asked questions. And on top of that, we have integrated the same thing into the vector db, so that let's say the question is from the FAQ, we have added one more tool. So let's say I have just given the suggestion that, let's say the question is present in the FAQs, then just call tool number one. The tool number one's responsibility is to search the answer only into the FAQs. If that specific answer is not present in the FAQ, then go for proprietary data, then go for other databases what we have integrated. So that's why we have added a multiple tools, or we can call it as a multi-agentic automation we have
Yeah.
done here.
You're
Yeah.
basically just chaining all these together essentially
Yes,
in
so
there,
we
right?
have
So
created that the same thing. We added
yeah,
multiple agent for that. So
yeah.
for we have integrated different APIs for that. We have added one more tool for extracting a data from FAQ. We have added a different tool for extracting a data from a proprietary document. We have added another tool, and the whole description we have provided into the prompt engineering. When
And
to
if it
call
is,
when.
yeah, and sorry, and if it is irrelevant, if it is irrelevant something asked, it will directly say, please ask something related to this in financial information
Yeah.
or something. So it will
Yeah,
directly
right.
prompt
So
there. Yeah,
you had an example earlier, Vishal, who won the World Cup. I'm guessing your system probably
Yeah.
doesn't allow users to ask like who won the World Cup or how about that test match last week? Anybody who won that,
correct.
right? So it's not gonna not gonna answer
It
those
will
questions.
not allow that. It will
Yeah,
definitely
yeah,
not allow that.
Yes.
Yeah,
yeah, yeah. Okay.
Yeah,
Uh,
and
yeah, go ahead.
one more last thing. So you asked the question related to the latency. So one more interesting feature we added, that is we have added some streaming response. So let's say
Mhm.
the same question we are discussing, who win the 2024 T20 World Cup. So the probably we get the answer in a different format. So initially we fetch the information from VectorDB. So match was held between India and the let's say Australia, and winner is the India. So we have added a streaming responses. So the each line will be printed. So it will not wait for extracting the whole data. Whatever the data extracted, that will be just give as a output, as a streaming output. I mean to say.
Mhm.
Yeah.
Yeah, that
So
makes a huge difference, right? So it doesn't have to
yes,
wait
yeah.
for the entire payload to come back. It'll start streaming
correct. It
immediately. That's
enhances the user experience basically.
yeah,
It
yeah,
doesn't keep waiting for that loading bar there, and it starts streaming. Like just like OpenAI ChatGPT currently we have, so we researched on that feature and then later on we added that too.
yeah. Uh, yeah, one more question. Uh, monitoring on the workloads and the analytics, are you employing any kind of monitoring and telemetry for the solution? I mean, I know you have App Insights on there, but what kinds of things are you looking for or concerned about or keeping a close eye on as you deploy these IDF
Yes.
solutions?
Yeah. So basically, if we talk about any LLM, so currently LangChain has a very huge capability, but there is one part LangChain is currently missing. That is the how we can say like our model is performing well, how we can evaluate our model based on the responses, or we can say how we can evaluate our model. So that capability is not with the LangChain right now.
Yeah,
This is my understanding. So that we have uses one of the tool called true lens, which is an which is we have taken, which is developed by the IBM. I have taken from the open source. So with the help of this specific tool, we can monitor the so many things like the quality of our answer, the performance, the metrics like a precision recall, context relevance. So that we have integrated here, so that I can able to see the different score like a precision recall of our answer. And from that answer only, we are like strict with the strict with our results. Like let's say if you are getting a little low and low performance or the accuracy, we need to fine tune model. So that kind of modeling, or you can say that kind of parameters we added for the monitoring and the looking at the logs or the alerts.
yeah, fascinating. That's super. that's becoming increasingly important as people are putting these into production is, okay, I've got
Mhm.
this thing and it's out there and working. How do I make it better? Like, how do I make it more effective, better answers that are generated? How do I make better queries for the vectorized data that I've got? How do I make it cheaper or make it faster? There's all these DevOps, or I don't know if you call them
Yeah.
rag ops. I don't know the new there's all kinds of new words or terms being thrown
Yes.
around, but
Yeah.
it's kind of that same thing, right? Like I've got something in production. I need to be able to monitor this thing, but also I want to be able to optimize it and keep it running well. So that's
Yeah.
great. Yeah, not surprising
Yeah.
you're doing that, but it's great to hear for sure.
Yeah. And even we are monitoring the time taken at every stage. So
Hmm.
we've coded in such a manner that at every stage what is the time taken, so that we can focus when it is there are issues, we can focus on those chunks and maybe
Yeah,
optimize the code further and try to resolve those areas. And we have achieved a lot. Initially there was a lot of gaps, and then we bridged those gaps by optimizing the code further, and we achieved a good amount of reduction in the time, processing time.
yeah. This is very cool. I want to put up just a link for a video. You want to just talk kind of a quick second about this video? Um, this is just about it's about Bizmetric, or is it about the
Yeah.
solution you built?
Is it this is about Bizmetric implementing various Gen AI applications on using Azure services and Azure Cosmos DB. We have given some insights on the application also. So that link, anyone can go and use that link to see the capabilities we have for developing the Gen AI application.
Okay, and then they can learn
Yeah.
more about Bizmetric as well. And if they
Yes.
want to learn more about building Gen AI applications or more about what you've built, these solutions you've built, they
Yes.
can find your information there as well, I suggest.
Yeah. Thank you so much, Mark.
Yeah. Hey, gentlemen, Vishal and Ishwar, it was great having you on. This is a great solution. Love to have you guys back and show us more cool stuff. Particularly the multi-agent framework stuff, I think is really getting increasingly hot right now. I guess you could say
Yeah.
everything in this space is hot.
Yes. Yeah.
But this is a great solution. I think you've really hit an important pain point for a lot of businesses that have built and have these IVF solutions, and increasingly we're seeing these more chat-based ones
Yes.
as well. And I think they
Yeah.
really do serve a very important need in just providing a better customer experience for your customers and our customers.
Yes,
So
definitely.
yeah.
Yes, yes. It has solved, it has reduced their cost by 40%, 40 to 50%, and we are very happy with it.
Yeah, that's a great statistic right there,
Yeah,
right? Is will cut your costs
yeah,
nearly in half and
yeah,
give a better experience for the customers at the same time. It's
yes,
great.
yes,
So, all right, gentlemen, thank you so much for joining us on our show. And thank you, everyone, for joining us. We're near 100 shows. Stick around, we've got some more coming.
yeah,
So, thanks for watching, and we'll see you all next time. Thank you, everyone.
yes. Thank you so much.
Thanks.
Thank
Thanks,
you. Bye
Mark.
bye.
All
Thanks.
right, bye bye.
Bye.
Thank you, Mark. Bye bye.
Bye.